We're back on section 3.3, and this time we're talking about differentiating a quotient of functions. So with product rule was the derivative of product of functions, and now it's the quotient of functions. First step, as usual, what we do is we write because plan is to connect the derivative of any quotient of two functions, the derivative of the functions themselves. What we do is we use the limit definition of derivative. So what is the limit definition of the derivative? That would be, for this case, it's equal to f divided by g of x plus h minus f divided by g of x over h as h approaches 0. And that, if I expand it out, f over g of x plus h is this term, and f over g of x is this term over h. So first thing that comes in your mind is to simplify this, simplifying this and seeing if it's going anywhere. So when you simplify this, you get f of x plus h. It's going to be equal to limit h goes to 0. And here, a common denominator gives you f of x plus h times g of x minus f of x times g of x plus h, and divided by the common denominator. Oh, my fraction line is a little low, so let's take it a little higher. Over g of x times g of x plus h divided by h. Now, this is complex fraction, fraction over fraction. Do what you need to do, numerator times the reciprocal of the denominator, and that becomes basically limit as h goes to 0 of f of x plus h times g of x minus f of x times g of x plus h divided by h times g of x times g of x plus h. And from here again, I'll look at it and I see that I don't see the derivative of f of x plus f of x or derivative of g of x there, but I see that there's the hope. So eventually you will learn how to add and subtract, what term to add and subtract to make a good sense for each case. But in this case, I see that I should probably add and subtract something that match up with this and match up with that. And so I can have basically f of x times g of x, so I get all the terms that I want. And it's both from experience and sometimes with knowing what the result is, although we haven't told you about the result right now in this specific case. So again, we decided to use the trick of adding and subtracting f of x times g of x. And so the next step is, again, like we did in previous problem, we put these two together, then basically first step is bringing the limit to the numerator and the denominator, so it goes both ways. And then in the denominator, it's going to be limit of the first group plus limit of the second group. And that's how it works. And then when you bring the limits inside the numerator and denominator, you notice what is constant in terms with respect to h. And g of x, for example, in the denominator is a constant. So g of x down here is a constant and comes out of the limit in the denominator. Over here, out of these two terms, again, g of x is constant and comes out of the limit. And then over here, f of x is constant with respect to h, and it comes out of the limit. And now you can clearly see g of x times the limit definition of f minus f of x times limit definition of g divided by g times the this limit as h goes to 0 of g of x plus h. Again, g is differentiable, it's hence continuous, hence that is actually equal to g of x itself, that this limit part. So a lot of this discussion basically goes with the fact that g of a cannot be 0 and the limit of g of x plus h cannot be 0. Now, what did we say about the quotient rule? We're just basically saying that if f of x and g of x are differentiable at x equal to a, and g of a is not equal to 0, then f over g of x is differentiable at x equal to a, and f over g prime of x is equal to g of x, f prime of x minus f of x, g prime of x over g of x to power 2. There is a song, I think, that goes with this. It goes like as low d high minus high d low. So low, that's a denominator, d high minus high d low over the square of the low. We go. In that song, a lot of times people make mistakes and place these two terms in a second by singing it as high d low. It's low d high first minus high d low, and so that's very important to follow that. Otherwise, you have gotten the wrong answer. If you change the order, you get negative of the derivative, basically the correct derivative. So it's very important to keep the order. So let's do a few. Minus derivative of square root of x is 1/2 times square root times x to the power negative 1/2, and so and divided by x still. So here it makes sense. And remember, x to square root of x actually is what? Is x to the power 1/2. It makes sense to factor out x to the power negative 1/2 and 2 to the power negative 1. So what would that bring us to? 2 to the power negative 1 and x to the power negative 1/2. This one has 2 divided by 2 to the power negative 1 makes 4, as x, and x to the power 1/2 divided by x to the power negative 1/2. Put all the same bases together, you get x squared. And there, everything is factored except x squared plus 1. Distribute the negative sign and the denominator here. And so you end up with, take these two to the denominator. I'll clean up this one. 4x squared minus x squared is 3x squared. Oops, sorry. And it would be 3x squared minus 1 over 2. This is x to the power 3/2, or square root of x to the power 3. Question: was quotient rule the only way to do this problem? Actually not. there is another way, and maybe a little bit easier. That's when you simplify inside by dividing each term in the numerator by the denominator. And this means that that's x to the power 2 over x to the power 1/2 is going to be x to the power 3/2 plus 1 over x to the power 1/2 is x to the power negative 1/2. The derivative, the exponent comes down, x to the power 1 less, which is 3/2 minus 1 is 1/2. And then plus negative 1/2 comes down, x to the power 1 less, which is negative 3/2. And then if you clean this up and factor x 1/2, x to the power negative 3/2, what you end up with is 3x to the power 2 minus 1, which is exactly the same one up there. So we gave an example with that you can do both ways, with quotient rule or without quotient rule. Let's do an example that is not possible without quotient rule or some other rule that we haven't learned yet. So this is the example. Again, this is high, this is low, so it's low in parentheses d high, which is derivative of e to the x, which is itself, minus high, which is e to the x, derivative of low, derivative of 1 is 0, derivative of e to the x is just e to the x. And now distribute, and you get e to the x plus e to the x times e to the x, which is e to the power 2x, minus e to the x times e to the x is e to the 2x over 1 plus e to the x to the power 2. That simplifies to e to the power x over 1 plus e to the power x to the power 2.